Okay, this lesson is 2-6b, nonlinear inequalities, and this time we're talking about the rational inequalities. Last time we talked about polynomial. So rational inequalities are solved similarly, except for one side must be written as a single rational expression, and the other side is 0, just like we had before. Okay, these are the fractions, y'all, and this is similar to what we just talked about in 2.5. Okay, you're going to see that stuff coming back to you. Okay, so if I have x squared minus x minus 11 all over x minus 2 is less than 3. Okay, I have to bring it to one side. So when I subtract the 3, it looks like this. And it says, of course, that it's less than 0. But if you remember from 2.5, I have to get a common denominator. So I'm going to multiply the top and bottom by x minus 2 over x minus 2. Okay, then to simplify that top, okay, I have to distribute that negative 3. So I'm going to have minus 3x and then plus 6. Let me come up just a little bit. Okay, so then I'm going to simplify my numerator, and that's going to give me x squared minus 4x minus 5. And then I'm going to factor the top. Again, I have a simple factoring because I've got x squared, which is x and x. And this time I'm looking for the factors of 5 that subtract to give me negative 4. Okay, well, y'all, I'm looking for the difference of the factors of 5 that give me 4. There's only 2 factors of 5. That's 5 and 1. And if 4 is negative, then I know that my 5 will be negative and my 1 will be positive. So that leads us to my zeros, which are going to be 5. And a 0 here, y'all, is anything. Normally we would talk about, if we were talking about graphing this, it would just be the top. But this has an effect on our answer, so I actually have to list all of these. Okay, so when I list them all, I actually put an X underneath my 2 because it's in the bottom, or you can cross it out however you wish, because since it's in the bottom, I know it can't be my answer because there's no way that it can't be equal to 0 in the bottom because we've already discussed that. That's undefined. Okay, so I'm going to go make my number chart that's going to have negative 1, 2, and 5, my number line, with my sign chart. I'm going to go pick a test value in each region, and I usually like to figure out where 0 is first because that's the easiest one. So then I'm going to have negative 2, and then 3, and then 6. Now, I have 4 regions I have to test out. So this is an example where you don't want to do the end behavior one like we did before. You actually need to test each of the regions. And if you start with all the way to the right, it's always going to be all positive terms, y'all, because when you put 6 minus 5 is positive, 6 plus 1 is positive, and 6 minus 2 is positive. So that one will always be positive. Now, all the way to the right, unless, of course, I have a negative sign out front. There's always an exception. Okay, so when I plug in 3, 3 minus 5 is negative, but these two are both positive. 3 minus 2 is 1, and 3 plus 1 is 1. Okay, when I plug in 0, I get to ignore everything, all the x's. So I have a negative 5, positive 1, and a negative 2. So I have a negative and a positive up top and a negative on the bottom. And when I plug in negative 2, they're all going to be negative. Okay, now I went ahead and circled that one because I go back up here to that factored form is less than or equal to 0. So I'm looking for the negative regions. Okay, 3 positives does not give me a negative number. But here, so whenever you have an odd number of negatives, it's going to be negative. These 2 negatives are going to be positive. So this region is positive, this one's positive. We have the region between 2 and 5 being negative, and this region being negative. So when I write my answers, I'm going to have negative infinity to negative 1. And then I'm going to have 2 and 5. And I stopped because I wanted you to remember we said that 2 cannot be a root. So 2 is going to have a parentheses, but our original problem is equal to, so the negative 1 is going to be equal to. And the 5 can be equal to as well. So that is our problem. If I worked out the other 2 on there, but they're quite lengthy and I want to keep it short. So if you have any trouble following those on our calendar, please don't hesitate to email us or come see us. Thank you so much, and y'all have a great day. Bye.